Hello everybody. Today we're going to talk about free BSD source. Okay, these are some of the basics of how to write an operating system. Why do we need operating systems? Because the basic procedure of any kind of functioning of any kind of computers or other kinds of systems and other things needs what is called an operating system. Operating system is nothing but a set of software. Software is called what you write as a code and other things. So that is why it is called operating system. So the basic things of an operating system is a kind of how you operate a particular machine. Okay, say you have a machine, any kind of machine. Okay, so you want to write an operating system for that. That is how to operate the system, like in software, to control and manage this kind of hardware which is there in there. And mostly these are uh, hardware can be any kind of platform. It can be 386, 486 and other kinds of processor, and other different types of processor are there, and different types of architecture is there. But as for assembly language and the machine coding is there, and over that you have what is called a operating system. What is the basic things of an operating system is what we are going to see today. Okay, so we have taken a source code for free BSD. So this is the top level of the free BSD source directory. Okay, so how to get there? First thing, you have to write down GitHub FreeBSD src. So if you go to click on that, so you can just go and have a browse and view code. Okay, so that is how where it is. So there are plenty of archives for other kinds of systems like Microsoft OS, Windows OS, and Mac OS and other things. But the basic operation of a particular operating system depends on what are the things. That is the whole thing we are going to cover here. Okay, so in order to understand these things, I have to show you how it looks like and those kind of things. So how to write a minimal operating system so that it can just function any kind of computer or any kind of iOS and other things. Okay, so or an Android system or any kind of things which are going to use some kind of microprocessor. Their microprocessor can be anything. It can be an 80, 85, 88, 81, 81, 81, 86 and all these different kinds of. Some things are kind of like uh, network processors and other things, but we are not going to so much of details about other things. But right now we are going to just look into some of the things, how to write basic things of how to write a operating system over a hardware so that you can use that for future things. Okay, first thing, you need what is called a compiler. Compiler is the one which is going to compile and make the operating system and decode all the different kind of higher level language and reduce it to a lower level language and finally into a machine language. Okay, so what is the standard procedure of a kind of compiler is first going to take your C code, then it is going to parse the C code and convert it into some kind of assembly for that particular kind of machine. Okay, then after that, from the assembly kind of particular kind of machine, it is going to completely convert the whole thing into what is called a binary. Binary is the final thing which is there. So that will be developed. It's a kind of so the entire operating system will be done on binary. That is the final thing. Okay, before that, if you want to know how to write an operating system, you have to take some of the higher level languages to know how the directory structures and other things can be there, so that you can use them for your final development of any kind of operating system and other things. Okay, so that is why we are here. A large community has continued developed it for more than 30 years. It is advanced networking, security and storage features have made BSD the free BSD the platform of choice for many of the business websites and most pervasive embedded networking and storage devices. The copyright information, please see the file copyright and other access for the other. Please see the specific source directories for more information. So there is something called source directories on which you are going to write this. So there will be a structured kind of source directory. Okay, this structured kind of source directory will be what will be used for creating the operating system. So the BSD has a specific kind of structured kind of things where they put in things, and they create the operating systems. So some of the things are like, the first you have to look into what kind of directories you have to create. Okay, so first you have to understand an operating system. So to understand an operating system, there are three basic things. Okay, one is called a file table, then you have a process table, then you have a inode entry, inode table, then you have so there are different kinds, about 3 to 4 different types of tables. Okay, these tables, what do you mean by tables? Tables is nothing but a kind of like, ordinary tables is like kind of like see, you have here directory, description, bin, system, user id, command. So this is the some kind of table formation or chart formation. So this is what is called a table, or a you know so the basic thing, it has got a table. Okay, with that table, what kind of tables are those things? Okay, the basic things of tables are, one is called file system table. Okay, so there will be a file system table, that will be a kind of thing which is going to manage all your files. Okay, so the files can be of different types, and variables and other things, and different kinds of structures will be there. So that is be used as a file table. Then you have what is called a process table. Process table is another one which is going to create the process. Create the process is initiate the process of what you have to do. Say if you want to drive a car, you have to first set in the kind of a switch on the key, and make it functioning, get the engine rolling. The next step is to get the engine rolling. Then you have to switch the gears and make it to higher speed. This is the process orientation. So there are two things. One is process orientation, and so functional aspect, and you have what is called a data aspect. Okay, so you have memory tables also. So there are three things. Basic thing is, what are the things? Memory table, process table, and file table. Okay, so these are the things. Okay, with these three things is what you write an operating system for any kind of systems. Okay, so these three tables have to be created before you control and manage the entire system. An operating system nothing but is going to control the system, a particular system or any kind of processor or anything. It is going to control all the things. That is why it is called a operating system. So NIOS is an operating system, BSD is an operating system, then you have Linux is an operating system, Mac OS is another kind of operating system. So each one has got different types of file tables, and different kinds of process management, and multiprocessing and single processing is also there. So you have single table which you have to do the processing work, then it is called a single process system. Usually it is a single process that is run. So you need a process, you don't need actually a process table for developing a single process system, but for other things you need a single process. So the basic things, you have to manage the files, you have to manage the memory, allocation, and kind of things, memory allocation, other things, and finally you have to manage file tables, memory table, and process table. So these are the three things you have to have very clear about writing an operating systems. So these three things will mingle with each other to run the entire system. So that is how they operate. Is they first read the file table, they read some of the things from the file table, then put it in the memory, then they equate the whole thing into some kind of process table is created, and process table, from the process table each individual process takes over. Then after that, it is the memory table is first read, and from the memory table it is aligned, and from the file it is read into the memory table. From the memory table it's called a cache. Okay, it is called a cache table or a memory table. And from the memory table you create all the different kinds of process table, and finally once you have the process table, then you have the whole thing running the process, each individual process. Okay, there are many different kinds of process table, like user process table, then system process table, and those are all depends on what kind of process is being run on the system. Usually the operating system takes over every kind of process that is running on the system. Okay, that is the one thing. Okay, then after that you have user processes. If you want 3 or 4 multi-processing system, and you have multi-processor systems, those things are all quite complex, but the basic thing is the same thing. Okay, so you have a process table, you have a memory table, and you have file management table. These are the basic things about any kind of operator. IO table. IO table is another one which is going to keep track of all the input output. Input output is the kind of thing which is going to come on the screen, the voice, the typing commands, those kind of things. So these are the 4 different parts, aspects of an operating system. And once you have these things very thorough, then you can easily write an operating system. So the first thing we are going to see is the different kinds of directory structures which we are going to see. The first thing is called a bin. Bin is what? Binary systems, where it is going to keep all the binary commands. Okay, say if you're giving a command to a particular process, okay, ls, okay, list the what is there inside the list the number of files. Okay, so bin will be the thing, so it will be a binary content, so it will be all binary tables which has only the running kind of code. Okay, the running kind of file. Okay, so bin will be the directory in which the running code will be there. It can be either it can be an operating system code, or it can be a user system code, or different kinds of things that can be there. So bin is the one which is going to be there. Then you have CDDL. Okay, so development distribution license, those kind of things. Then you have package contribution by third parties. Then cryptos, or crypting, any kind of crypto, you want to do any kind of crypto, stuff, like password and those kind of things. Those things are done by crypto. Etc. is the one. Template files for etc. Etc. is etc is just an extra command where there's a small kind of table which is stored for different kinds of what kind of limits and bounds and how much it should be run. Those kind of things are all the template files. It is stored as a kind of template to work on. Say if we want to create a file table, then number of file tables will be created as a kind of etc file. Okay, there it has number of file tables, what kind of structures will be there, those kind of things will be read from the etc. Okay, of different kinds of configurations. Usually it is supposed to do with configuration is like, like what kind of operating system you are going to write. Okay, is it going to use huge memory, is it going to use less memory, it is going to use flash. Those kind of all systems are what is called a configuration. Those configuration information of about all the things about the process and the kind of architecture, everything is going to be /etc. GNU is the what is the kind of commands, other things that is available. So the different kinds of commands you can give: ls, copy, trace, and these kind of small commands that you can give to the operating system. Those things are what's the GNU command. Those GNU commands are the standard library commands where you can give the set of support infrastructure that can be set of commands that is supported. Okay, so what are the, say for example, ls dir, then window, then the window, or you can type in process, read process table, rps, also read process table. Those kind of things are all, they are all GNU commands. Okay, so open up a file is f open. So those kind of things are all GNU file table system. So include is what is called the include file. Include files is something to do with different kinds of prerequisites kind of things, which are small kind of includes which will be included, so that you can develop all the different includes for different kinds of, whether it is for IO, whether it is for memory table, or it can process table, or it can be file table. So these are the things for kind of, and other things are there like kernel locking, then locking the things, then what is the other things that are there. As we go along, we'll find out other things which are going to be in there. So for right now we have then rescue, then we have sbin. Sbin is the system command bin. Okay, so all system commands will be there in sbin. Okay, bin will be the standard thing where we have the whole thing coming in. Okay, different kinds of where it have all the complete OS bin and other things will be there. Sbin is system commands bin. Command itself for different commands, it's a kind of process. It's an extra process or a user process which is going to be there. Then user base, ubin is the user bin, but we are just looking at the operating system alone right now, so that is why we don't have other kinds of bins right now. Okay, secure is there. Then share what kind of shared resources you are going to use, whether it is going to memory, going to be you are going to use the memory shared resource, IO shared resources, those kind of things are all there. Stand is boot loader sources. Okay, the basic boot structure once the first initiating commands. Initiating commands is the kind of one which is going to check all the IO commands. It is going to check where the memory is present. It is going to check how the processor is, whether it is running or not. So that is the basic thing that the bootloader sources will be there. So that is the some kind of diagnostic and those kind of things will be there in stand. And then kernel sources. Kernel sources is the basic kernel that is going. Kernel is a kind of layered kind of structure architecture. So the internal will be some kind of process. Then will be outer kind of thing which will protect, which won't allow you to enter beyond that process into the operating system. So yes, a user process cannot enter into the kernel into the actual OS without a something called what is called a gate. So using gate, so that is called kernel sources. Okay, sys config, then test, regression test, then tools which are utilities that you are going to use, those kind of things. Like if you want to show the process table, if you want to see the file table, those kind of are all supported to. User bin is the user commands that you can use. As user has been the system administrative commands of the user bin. So it's system administrative. If a user comes in, okay, I am like say somebody, okay, then after that those kind of commands which are going to be used by the user, it's called those commands are all user bin, and user has been is the system administrative commands of the particular user. Okay, those kind of things are there. So these are the basic directory structures which you can look into the thing. Okay, now we are going to sources straight away. Okay, these are the packages that are in there. So we see view code. Okay, so now if you go into look into this, so these are the basic directories you have to create. What are the different directories you have to create? Dot cirrus ci. Okay, so it is a kind of cirrus ci is a specific kind of what kind of source from which, okay, it is going to get. So that is CSCI. GitHub is the one which is going to use the GitHub for getting the source code and other things. So that is why you have one directory for cirrus ci and .github. Then after that you have bin. Bin is the one I told you. It's a binary. All the binary OS binaries will be there. Okay. So those things are all will be stored in there. Then CDDI. Okay. CD is what CDDL or CDDL. Okay. So CDDL is another one. Okay, we'll look into that later. What is the CDDL? Okay, contribute different kinds of contributions. The crypto is the one which is going to do the the password, those kind of things, all these things, crypting, the encryption, decryption, those kind of things will be there in the crypto and other things, etc. I told you already. It is going to have the some kind of information about the GNU is the source. Okay, GNU is the source. Hash include is the one which is going to have the include files and other things. Okay, Kerber OS 5. Okay, what is the specific OS that is being so it was developed by Kerber OS 5. Okay, lib is the library. Library is the one which you have in order to develop all the different kinds of file management, process management, memory management, and IO management, all these four different types of things. For that you need all the libraries, okay, for running the operating system. That is why you have libraries where you can call the things as and when required. That is why it is called library. You don't put all the things in one place, so instead of that you call it as a library, link all those libraries, and library exec is running libraries. Okay, runtime libraries are kept as libexe. Okay, exec for executing some of the things, executive the library, that particular function or functional call or something like that. So release is the one which is going to keep track of all the rescues. Another one, sbin is the one which is going to be having all the system OS bin structures and the source for the source and the secure. Okay, secure, share, then standalone kind of. So if the system is going to go under standalone kind of thing, then it is going to have all the different support structures for those stand. Okay, so this is the one which is going to system things. Okay, what are the system things, how much memory is used, how much is this thing, those things are all and comes under system. Targets, then different kinds of targets, what kind of machine you're going to run, those are all dependent, those kind of information is all put in targets. Test is the one which is going to run all the tests. Okay, whether the IO is running, the processor is running, those kind of things are all tests. Tools is the one, support tools, which you want to find out what number of process that is running, so those support tools will be a user bin and user s bin. Okay, now AR config is the one which is going to be arclint. Okay, this is on arcs or YMI. Okay, these are all the basic things that is going to you are going to include before you're running all the operating system and other things. So you have a copyright and maintenance make file. Okay, finally you have the make file. Make file is the one which is going to build the entire operating system for you. It will specifically give all the directives to entirely build the entire operating system. Finally have the operating system OS code developed. That is why it is called the make file. Okay, so that make file will do everything for you. Okay, before the make file is being, so first thing you have to look into the make file. So first thing we'll just go generally look into the make file. Okay, this is the basic thing which is going to be there. So if you go into the make file, it is going to be a C code which is going to have all the kernel directives and other things. Okay, so this is all the make file. Okay, so what it is doing, it is doing order. Okay, order install word. So it is going to call build world install world. First thing it is going to install. Then you have distribution directories, distribute world. So these are all functional calls. Okay, make functional calls. So it is going to do one by one all the make. So user commands command structures will be called and things like that. Okay, so these are all the different kinds of path that will take. Okay, different kinds of path before it is going to compile, link, load and all these things together using these path structures. So these are the initial things you have to give for the make file to build the entire operating system. Building means it is going to make the entire operating system from the C code into assembly code and finally into binary code, so that you can have the operating system taken out and then you can install the operating system on some kind of specific targets. Okay, targets is the one which is going to be the kind of machine language that is going to be in there. So these are all the definitions for those things, and you are going to do all the control structures for how to, where the directories will be, how the kernel directories will be, where it is going to be there, and which file you are going to take, link, load, compile, do all the things. Those things are all for the building the entire operating system is what is called the first make file. This is the initial make file. Okay, there are other make files which are for other things, but this is the basic make file which will do the entire build the entire operating system for you and remove some of the unwanted state, and it will do the all the free BSD. So this is $free BSD common user driver targets are from universe. Okay, ringer box, worlds, kernels. Okay, so kernels will be done, only the worlds will be done, world will be there, which is going to be world. Okay, then you have kernel tool chains, all are those kind of delete old files, list old directories. So if you want to remove some of the old directories after the building the thing, you have to remove some other directories and keep on installing new, compiling new things, creating all the libraries, those kind of directories. How to make all these things and build all the entire structure for the operating system is given what is called a make file. Okay, so we go back. Okay, then that is the make file. There are other support make files which are inc, then libcompat. So the libcompat is going to build all the libraries, includes, is going to compile all the include kind of things, sys include, then files include. Okay, so these are the basic make files that is going to be there. So 1 2 3 around 4 make sub make files. One major make file will be there, and these are all other sub make files which is going to be doing all the inclusion. Readme is the one which is going to tell you how to build all the things, and release notes and all of these things are all included. And some of the things, like if you see dot 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 kind of thing, dark archive, dark, those are all binary which is already present for initiating those things. It is just a binary code, straight away you plug into the system depending on what kind of architecture you want. Those kind of binary kind of things will be there. That is for initial kind of things. Okay, so this is the directory structure. Then you show this thing, then you have library and GNU, etc., and other things. Okay, so if you want to go see one of the things, okay, we'll go into how to build the, so we go into what is called, okay, bin. Okay, so first different kinds of bin is there. So first we'll go into the bin directory and see what is there inside. Okay, so this is called a cat command. So the binary, when you say cat means it is going to print all the things from the directory structure from the on the chart. So the cat command is ch flags is the channel IO command is will change mode. These are all the commands that is going to be there. Bin commands will be there. This is the OS commands. For this, the source code is within that. So cat command will have the source code within this cat. Okay, so if we go into cat, we'll have the source code, the make file and other things for all the things, and test tools and other things. Cat1, cat the cat.c is the actual uh, cat file. Okay, so that is the command file. Okay, that is a command file that is going, it is going to include all the basic string.h, libcompare.h and all, and it is going to do, when you say type in a command called cat file 3, cat file 3, cat file 3, it is going to just cat the whole thing on the, that is put the whole thing on the string. Cat means printing the whole thing on the string. Concatenate. Okay, so concatenate shortened form is they use cat. Concatenate something, concatenate a file means you show the file on the screen. That is why that command is given as cat. Okay, so all the commands are stored right there. So this is the source code for that particular cat command, and you have the build for those kind of things, and you have the test for those kind of things, and that is why it's called the cat command. So different kinds of commands that is there. Cat, ch flag, check flags, check IO, input output, then change mode, copy. If you go copying one file to another place, then you copy file 1 to file 2, create a new file. So CSS, so if you want to spawn a particular process, CSS is that if you want a subshell created, so it is CSS will be there. Date will be the thing which is supposed to do the display the date on it. DD is another one. DD is the command which is used for develop the disk. Okay, so controlling the disk commands will be all like DD, DF. Those are all something to do with disk. Okay, so how to control a disk and how do you take the memory from those kind, and how to read the file from the disk, and those kind of things are all this. Domain name something to do with the network kind of things which are going to be inside those things. So if you give the domain name of you type in the command domain name on an Unix operating system, then that complete support structure will be created here. Okay, the complete source code, and so if you say domain name, we go in here. So we have a make file, make depend domain name.1, domain name.c. So the actual domain name.c is the actual C language file on which it is going to, the complete command is going to be written like this. Okay, that is what. So if you want to see how domain name, so we are taking one particular thing and seeing what is going to be. When you say domain name on a Unix operating system, you type in the command domain name, then what it happens. So how it is defined. So first it gives all the include files, those include files. Okay, then it says it's the free BSD source code, then sysparam.h parameters, the system parameters will be there. It includes all these things too, because you're going to call these things within the file main function. Yeah, those things are all included here. Okay, the static void args, then main argument, then you have define inside, then domain name. Okay, domain name is max host name m length, so that is where it is going to read. So it is going to use the command called getopt. Getopt is another command which is going to use from the system command. Okay, the getopt is a system command, and this is overrunning on the getopt kind of system OS system command. Okay, then it takes the argument and operand in and displays the thing. Argument set domain name argv string length and get domain name size of, and then it displays on the screen those kind of things. Okay, then finally it prints fprintf usage domain name, so it is going to print the thing as the final thing. Okay, that's all. So it is going to read from the say process table, or here it is going to be host table. Okay, So there's another thing called host table. Okay, so domain name is for networking architecture. So this is a host table. From the host table, it reads the thing and gets the name of that particular host and then displays the thing. That is what is done by this small C program, and finally it prints the thing on the screen. Okay, this is what is done by the small C program written here just to get the domain name. Domain name is the host name or domain name. Those kind of things will be there. Okay, so this is how the different kinds of commands. ls is the listing. Okay, l and kill is to kill a process. So you have a process, you want to stop the process, those kinds of things. So real path, mdir, stty thing. So these are the basic commands. uid gen, test sync, stty, sleep, sh, and you have to learn all how to use these commands. Okay, so sh means it is going to be a shell that is going, it's a single command. Okay, rmdir is you have to give the directory name as the option and which directory you want to remove. So remove directory is the command that is given, and that particular directory will be removed from the directory entry. Okay, so there is a directory entry also, that is also another table which your file table is linked along with the file table. So this will remove directory structures will be there, including the files which is within the directory will be removed. So that is called the remove directory command. Mail, so mail is another one which is going to use remote mail. Remove is remove real path, password. So if you want to get the password, that command is given by pwd and the source for that particular thing is in here. So these are the basic structural things. These are supposed to be in bin. Okay, so let's go back. Bin is over, then cddl, then crypto, so etc. If you go into etc tables, you have what is called gnu, mail, entry, root, send mail, temp cap. So how to make all these things is there. Okay, so this is for encrypt, that is what you are going to see. Okay, etc. Okay, etc. entry and send mail, and the make file for those particular things is present. Master password and other things are all for so if you want to see the root. Okay, so if you go into the root, dsk, so this is a complete kind of login kind of structures. So etc file is a fixed kind of thing which is already present. So it is some kind of encrypted code that is present for that particular root directory kind of thing. Okay, so how to make those things will be done later. Okay, etc is a kind of table which is going to tell you what are the make files, where the things are there, and those kind of things are there. Okay, so what is the kind of file table, which file table is there, process table, how much process table, those are all fixed entities will be there in exe. You are not supposed to touch etc. Okay, so basically it will just kind of link. You can make etc, but you cannot touch any of the things which is. So these are the basic include files. So include file is the system include file is the .h, those kind of things. So the system will say here, if you take for one .h, what is this one? We'll see memory.h. This is one file. Okay, so this is memory.h. Okay, this is one file, and that is called memory.h. So it is using the memory references and what are things supposed to be for the memory, how to manage memory, those kind of things. Malloc is memory allocation, locate, link. So these kind of h files will include mq, how to queue the particular memory pool. Okay, memory pool, how to allocate memory pool. How to mq means it will queue all the memory. Okay, sequence all the memory and how to use them regularly, those kind of things are all. NLS type, then network type. So N means something to do with NList, NSS, those kind of words, something to do with it. P means parts, printf. So printf itself is a different kinds of printing on the screen will be done by printf. The support structures will be password.h is supposed to do the PWD password, so it's supposed to do with all the process. Regex is registration reading. All kinds of registers and other things will be depending on the register. What are the registers? IO registers, then memory registers. Then you have these registers are the hardware. Okay, the hardware content of the things. That is why it is called registers. So you are not supposed to use registers. The registers are most basically used only as a kind of accessing a particular location, like memory. If you want to access the memory, then you use register.x. Okay, if you want to access the memory, the IO, then you have registers for those things, and you have to access through the registers, and these things will be locked. Okay, locked and used. Okay, so when the process is running, it will lock that particular resource, and then after use the resource and then release the resource, those kind of things. So if you want a particular allocation of memory, it is going to lock that particular memory location, then after that make changes onto the write onto the memory location, then finally release the memory location once the process is done. Those kind of things will be. utemp is another one, and solid TTY so terminal types, all the terminals and other things will be dot references will be in TTY dot h. Okay, you time related things, you temp, temporary files and other things, user ID. So user ID is the related things will be in here. So these are the basic things of string.h, something to do with all the different kinds of how to format string, how to reverse a string, how to manipulate a string, how to invert a string, those kind of string structures will be there. So how to insert a string into a file, those kind of things are all given for pre-thread. Thread is the one which is going to the process. Okay, so process thread.h, process is for something to relate with all the process table. Okay, register table, process table, then you have what register is mostly for IO and memory and other things. Signal.h is another one. So all the signals are, you catch a signal, trap a signal, you wait for a particular IO, then that is called signaling. Okay, so that those things related information should be all in signal.h. Okay, so if you want to start up a process, the process is running, then after the process stops, it gives a signal back to you, then after that you release that particular process out of memory and remove all the memory contents of that particular process. This thing is by way of signals. Okay, the whole process is running by using signals only. So the process table with other things will be running by using signal. So one process, one user gets out, he logs out of the system immediately, it gives a signal, and then that signal is catched, and then he gets out of the thing, and then that particular system thing, memory or resource or anything is released. Okay, so this is something to do with the semaphore. Semaphore is the one which is going to lock a particular location, so it is waiting for a particular resource to happen. So those related information will be all what is called a semaphore. Semaphore is the basic thing that is used for process table, memory allocation, IO table allocation. Those kind of things are all done by using semaphore only. Without semaphore you cannot do allocation, deallocation, memory inclusion, running the process. Process also uses semaphore table for running the process and schedule the process and all the things. So scheduler is the one which is going to, the related things will be using the, so res updater, regex, then read, passphrase, ran lib. So the library runtime library will be all in the ran lib.h. So those kind of things, password, that pthread, the printf, then after that what nlist, network, some network related, and memory related. So memory related mq, mpool, monitor, mk, memory, malloc, calloc, all these things are all something to do with memory. L is the library kind of, the libgen, limits, link, locate, those kind of stuff. All those things are all done by for library kind of thing. Another k things is all for kernel dependent things. grp is for group id, password. So group table is also there. So group table, get up, those kind of things, those are all the different kinds of tables which will be used. So the basic things will be the four things. Then after that you can use other kinds of tables to manipulate the entire operating system. How to this is just a general overview so that you can have a look and write your own operating system, so that you have an idea of how to create a path, how to create the different, what are the things you have to put in different directories to create the, then how to put to make file and all those things, so that you can build the entire operating system. What are the definitions you have to take, memory.h, and what are the limits and bounds are the ones which is going to tell you, okay, I have only 500 GB of memory, I don't have those kind of, so the limits and what are the number of processes that can be done, and other things are all something to, so the command type and other things are there. Okay, so this is all the architecture. RPC protocols is the other one which is how to use a particular network protocols and other things. IE386, which is the architecture which is good. So IE386 is a processor, that is the name of the processor. Okay, IE386 Intel 386 processor. So those things related to all that particular machine i386 will be all here. Okay, all the make files, all the these things will be all here. Okay, so he does got just a general make file for those things. Okay, so then we go back. So liquor sources, text, and user bin. Also, I told you about what are the things, the command where you have to put all the commands. So this is the general directory structure. You have to first create the directory structure, then you have to put all the dot files to what are the different kinds of configurations you are going to do. Then you have to write all the copyright, and then you have to put all the make files in the first directory, and then finally release notes, updates, and all the things you have to put it in the first directory. And how to build the things, those are all you have to put it here. Then you have to create the directory, user as bin, user bin, tools, tests, all these different targets and other things. Say about how many things are there, 1 2 3 4. So if you first remove the first two, then other things are the basic things which will be GitHub is because the source will be there. So so the basic things will be 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 directories are there. So you have to create around 22 directories to build the entire operating. The 22 directories will have it in a structured form of with makefiles and other things, and the basic main makefile will be here, and sub makefiles will be within those directories, and sub sources for all these things will be the within the particular. So the basic things you have to thing the make thing is sys. Okay, that is one major thing. Then tools is another one which is the major thing. Sys tools is another one. Then sbin is another one. Then release the libexec is another one. Lib is another major directory. Okay, these are the things which are the major directories. Of include is another one. etc is another one, which are the major kind of. Bin is there. So these are the major things. Kerber OS. Okay, so these are the major secure. You don't have to have even secure and all, but other things are all needed. The basic things are absolutely needed. User bin, sys, okay, etc secure has been. Then after that release libexec, kerberos, include, gnu, etc, crypto, contrib, cddl, bin. These are the basic directories that you have to include, and include all the things within the thing, how to build the operating system. So we just looked into some of the things. You know some of the things, how to build the operating systems, how many directories as the main thing you have to create, what is the make file you have to create and everything, and what are the dot files you have to copy, because it is something to do with the Cirrus CI or GitHub. So you have to take all some of the dot files which are binary kind of thing, okay, which will be directly used to run the to run on a particular machine. So those things are all this dot config and arclint. Those things are all dependent on the particular copyright, and all those things are there. So this is the first directory, and other directories we can go detailed into each one of those directories later. So we saw one of the directories, we saw sys, where the system commands and other things will be present, how to write an operating system. So this is enough for today. So I think it covers most of the things. So if you want to write your own operating system, you can go. There are different kinds of operating, real-time operating, single user operating, Mac OS, in iOS, and all those different kinds of operating systems. But this is just a basic introductory so that you can get off from the platform and work for yourself towards achieving higher goals on operating systems. So I took 3 BSD because it was first developed back in 1981 by a California Research Institute, which developed all these things, back in 1980 or something like that. They started developing the first complete C scope. Before that, it was all by, kind of binary kind of thing, where they, write the entire operating system in binary, and then they dumped into the system and made it run. But after, California BSD, they wrote the first higher level language called the C, and that was the first C++. Before that, it was A and all, but those things, one C was the one which was dominating at the beginning. Of first higher level language was written as C, and then assembly codes were all different for each kind of different architecture and different kinds of machine systems. Okay, that is all for today as the basics of how to write an OS using the directory structures and other things. Okay, bye now.